Really interesting problem here with a lot of complexity to explore and also some really valuable big picture takeaways that will apply across a wide variety of questions. First up on the list of transferable strategies is if you see a problem solving question, you really want to look at the answers first and ask, what are these answers telling me, if anything at all? Certainly, there are many questions where the answers just aren't going to give you a whole lot of data, but on the questions where the answers do give you some data that you can use to strategize, it's so helpful that it's worth the questions that don't offer you any upside for looking at the answers. In this particular question, the answers are telling us that there aren't that many integers that satisfy this inequality that are less than 5. At most, there could be 5. And when you see small numbers in the answer choices like that, you might want to consider a quote-unquote alternative approach to the problem, rather than what I would call like a textbook or standard algebra approach to the question. Because even if we had to just sit here and list and count all the possibilities, which I'll show you how to do in a second, that's really not going to be that bad. It's unlikely to take us much more than 2 minutes. It's almost certainly not going to take us more than 3 minutes. And those are totally acceptable time horizons on quant questions on test day. So let's explore one of those alternative solutions, and I'll show you why this is a great idea on a question like this. So I'm given this inequality, and it's a little annoying to say the least. If I try to do the math and multiply out the top, the problem doesn't get easier, it just gets harder. So for those of you who have a strong instinct to just start doing a bunch of algebra on a question like this, you might want to start to shift that instinct a little bit, unless, of course, you got the problem right, in which case, great, keep doing what you're doing. If your algebraic approach was awesome and it was fast, don't change it. But if you had an algebraic approach that was too long, or you got stuck with the algebraic approach and couldn't make it work, then you're going to want to learn to recognize situations like this in the future where there aren't too many possibilities for us to discover, and the numbers that we have to test are relatively small. And at the end of the day on the exam, there's no style points. You either got the question right in a reasonable amount of time or you didn't. So there's no one looking over your shoulder being like, oh, did you use the official guide solution for that? That doesn't exist. If you have that kind of judgment on yourself, then now's probably a great time to just let that go and make sure that you have some flexibility in your approach on test day. So where's a good place to start plugging in some numbers and testing? Because there's infinite possibilities we can test, and we don't want to be sitting there testing infinite possibilities on test day. So first thing you want to start thinking about, and this is true of a lot of questions, is anytime you see something about anything being greater than, less than 0, it's always a question about positives and negatives. And that can put us in the right frame of mind for discovering a good strategy for getting a question like this right efficiently. So the place I personally would like to start is, how do I make it equal to 0? That seems like the simplest place to begin, because greater than and less than 0, there's tons and tons and tons of options. But if I can just make it yield 0, there's probably only going to be a few options that make that happen. And there are two ways that I can make this side of the inequality equal to 0. Either x is -2, which is going to zero out this term, zero out the numerator, and therefore zero out the entire expression. And then there's x equals -3, which is going to zero out this term, zero out the numerator, and therefore zero out the entire expression. And I'll show you a deeper way to strategize on this in a second, but what I like about this somewhat simplistic way of thinking through the problem is that it gets me some momentum. And momentum is huge, especially given how emotional the exam is. For most, if you're a robot, if you're cool as a cucumber during the quant section, awesome, don't change. But if you're like most people, I would definitely put myself in this category, it's gonna be stressful. It's probably not gonna feel good while you're taking the section. So any ground you can gain in any particular problem is valuable, because it increases your belief that maybe if I invest a little bit more here, things are going to work out for me. So that's what I like about this way of thinking about the question, even if it maybe ignores like a more slick strategy, or just maybe something that lends itself a little bit more to a textbook explanation. And in the world of momentum, what's good about this is I can get rid of A. And that's always great. Like having 25% odds of guessing with just maybe 30 seconds of thinking through the problem here is better than having 20% odds of guessing and being totally hung up on the problem and sort of getting into a negative mental loop of, how am I going to figure this out? I don't feel good about this. Maybe I should have pushed my exam date back a couple weeks. Like, those thoughts for a lot of people are just going to happen, and the journey forward is just learning how to deal with them well rather than trying to eliminate them. But if we can avoid them by getting a little bit of momentum in the question, that's, in my opinion, better than having to navigate them at all. So that's what I like about starting out with that. Just, can I zero it out and get some traction in the question? Now, the other thing that I really like about maybe just trying to solve a piece of the problem rather than feeling this emotional weight of needing to set the whole thing up in one elegant swoop of mathematics and get the whole thing right is that it can teach you something about the question. You can start to learn a little bit and strategize a little bit in the background as you're thinking about, okay, what can get me the result I'm looking for here? It's kind of like taking a few steps down a hiking trail that you can't see the end of versus needing to know every single turn in that trail in order to feel comfortable walking down it in the first place. Sometimes you got to just take the leap and figure it out as you go. So I think this is a good example of when that could work well for you on the exam. Okay, so now comes the question, where do we go from here? And there's really only two options because we started by zeroing this out, and the only two ways we can go is make it negative or make it positive. Those are the only alternatives to making it zero. Now, the nice news about the question is it can't be negative. So anything that's going to make this expression overall negative is not going to work. So really all we have to do now is focus on what kind of numbers are going to make this thing over here larger than zero. We don't even have to worry about less than zero, which is awesome. And when you're trying to do some discovery on a question like this, I recommend just plugging in something that makes sense to try to make some headway. Again, just take that next step down the trail and just ask yourself, is this a trail I want to keep walking down, or is this one that I need to just get off immediately because there's lions and tigers and bears and all kinds of stuff that I don't want to deal with further down the trail? I got to just back it out and find a new trail to go down. Now, if I want to start making this positive, then basically I just want to try to make everything big if I can. And everything up here, as long as x is positive, is going to stay positive. And I just have to worry about down here things becoming negative. So like, for example, I can see that if I made x equal to 1, the bottom of the expression is going to be 1 minus 2, which is going to be negative, and the top is going to be 3 times 4, which is going to be positive. Now, you don't even need to have that insight, but it's the kind of thing I'm talking about. I'm just thinking, how do I make this positive? And it's okay if I go through some things that are not positive because that's going to get me a little further down the path to getting the overall positiveness that I want to see. So what I would personally probably do here is just plug in 5 because that's my horizon. I can't go more positive with x than 5. So I'm just going to start with 5 and then work my way down and see what happens. So if I have 5, then I'm going to try to be as visually organized as possible. This will become 7 times 8, and then this down here will be 3. Well, that's greater than or equal to 0, so at least I'm on the right track, but it can't be 5, and it can't be 6, 7, 8, 9, 10, 11 either, so I've established a healthy boundary here. Now, if you were looking at the question and thinking x has to be an integer and it has to be less than 5 and you wanted to start with 4, that's totally fine. Like, that's really, really intelligent. I just don't know if all of you watching this are going to be thinking along those lines, and I want to give you something that you can go on if the going gets tough and you don't have that kind of insight. I think if you're having those kinds of insights on a problem like this, like, you're probably okay in the future. You're going to be all right. But if you're not having those kinds of insights, then I want you to have something you can do to produce an insight. So I'm kind of just talking worst case scenario here. So let's say that we do produce that insight for ourselves, or we just automatically have that insight and we don't need to test 5 in the first place. Then we'll go straight to 4 and we'll run the numbers. So that's going to yield 6 times 7 across the top, and then it's going to yield 2 on the bottom. And that's fantastic news. That absolutely works. This is going to be positive. And now I've got 3 different values of x that will make this greater than or equal to 0. So again, I'm getting traction, I'm making progress in the question, and I'm answering the most important question for time management purposes, which is, am I making progress? Am I actually getting closer to a solution? Because if I take a few steps down the path and things aren't looking good and things are just getting worse with every step I take, or I'm getting nowhere, then it's time to bail out on the question. But if I'm taking steps and things are going well and I'm getting some traction and I'm producing results and I'm increasing my odds of success quite literally here by eliminating answers, then that's a sign I might be able to continue as long as I'm not over-indexing. And if you want a healthy limit for how much you should spend on a question before it's just time to bail out, up to the 3-minute threshold is usually good, and then after 3 minutes, usually only bad things are happening. Now, there's many exceptions to that. If you want a super detailed timing strategy, then you're going to want something fully customized for you. And if you want some help developing that, just reach out to us and we'll do our best to support you. But if you just want a good, clean number, 3 minutes tops is great. If you're hitting the 3-minute threshold, it's time to just pick your best estimate and bail out. But let's be real here. Let's say I've messed around with this question, thought about it, and done some number testing. I would say most of us are going to be somewhere between 30 seconds and 2 minutes at this point in the problem. And with that 30 seconds to 2 minutes, we've increased our odds by 13% of getting the question right, which is not bad. Now, we also are close to maybe getting a couple more data points that are going to increase from 33% to 50%. If we were stuck here thinking, I don't know which numbers to test, there's an infinite number of numbers, I can't figure this out, that's time to just pick C, D, or E and move on and find something that is probably going to pay off. But if you're like, cool, 4 worked, let's try 3 because I can't go the other direction, then we've got a high likelihood of success here, and the extra time investment is probably going to play out in our favor. Again, it's really important to talk about this stuff because so much of what the exam measures is our ability to make great decisions under pressure. It's not strictly a test of our math skills. Yes, we need math skills to be able to speak the language of the exam, but a lot of it is about developing our decision-making skills, our analysis skills, and really just asking and answering the question, should we continue to invest in this project? And of course, the answer here is yes if we're in this situation. So we'll pop 3 in here. 3 plus 2 is 5, and then 3 plus 3 is 6, and then 3 minus 2 on the bottom is going to give me 1. So that's also positive, so that's fantastic. Now I've got a 50% shot at this question. Let's try 2, and many of you probably already figured out the first time through this question that 2 is not going to work out so well because I'm going to wind up with 2 minus 2 on the bottom, so I can't do that. We already explored 1 a little earlier, but let's say you're going down this pattern. You test 1 and you realize that's going to give you a negative result in the denominator and a positive result in the numerator. And at that point, you probably have time to test a couple more examples, like you could try popping in 0 there, but you're going to quickly see the pattern that the denominator now is just going to be negative no matter what we do. And that should hopefully give you the confidence to pick, okay, I'm 90% at least sure that the answer is D. And with these kinds of solution paths, I think what you're going for is as much certainty as you can get in 3 minutes or less. That's how I personally like to think about it is, am I building certainty, am I making progress, and am I under the 3-minute time threshold? And that's why I was bringing that up earlier. Because if I'm creating certainty, but I'm beyond 3 minutes, even if I get the question right, it's just too expensive. It's going to be 1 point for the price of 2, and like that gamble is just not going to pay off for me across the entirety of the section. So it's best to just halt there, in general, have a rule for myself, and just learn how to let things go better. But if I am making progress, then I want to utilize all the way up to 3 minutes, however long I need, to get the maximum amount of certainty. And when I realize that I'm plugging in numbers and my level of confidence that I'm making any progress is going down, that's when it's time to stop investing, make the best bet that I can, and then move on to the next thing. That's how I would personally do the question. I would just start thinking about, okay, what's this problem probably going to be hinging on? It's probably going to be something about positives, negatives. I have the option of starting with just making it equal to 0. I can clearly see some things that are going to make it 0. So let me just start there and see if that teaches me something about the problem, see if it gets me some momentum. I just start walking down the path and seeing what happens. And in this case, it worked out, which is awesome. And I already said if at any point it wasn't working out, I would have just picked whatever I thought was the best bet and then moved on to the next question. Now, there definitely is a very technical solution to this problem. So we'll explore that in a second, which I think is just a valuable conversation. And then there's other ways of strategizing that are going to wind up being largely similar to what I just walked you through with some variation. And I think what you're always trying to do with official guide problems on the quant section is figure out what's going to be your best plan of attack for situations like this in the future. And really what you're doing across your prep is just collecting those moments of pattern recognition, like what I was talking about right here and right here. Okay, it's a problem-solving question. Now, there are some more technical ways of processing this question using like a pure algebra approach. And then there are a couple other ways of strategizing that are a little bit different, but they're kind of just different flavors of what I just walked you through. So at the end of the day, I think there's really 2 main viable solution paths. The sort of algebraic reasoning and testing numbers, which I just walked you through one version of. And then there's the pure math, ultra technical path that you can go. And then there's a couple different versions of each. And I think what you're always trying to answer when you're practicing quant questions is, what's the kind of thing I want to think in this type of situation in the future? Because on test A, you're never ever going to see this exact problem again. That's not the way the exam works. They never recycle a question verbatim. But you'll see questions similar, or you'll see questions that have similar elements. And that's a lot of what you're trying to develop throughout this process, is a strong pattern recognition. So I've given you a couple things right here that are good pattern cues. Okay, if I see greater than, less than, or equal to 0, it's probably something having to do with positives and negatives. And so I want to be thinking about what would make it positive, what would make it negative, and what could potentially make it 0. And you can see that was kind of the seed that sparked my approach on the question. And I combined that with another pattern recognizing principle, which is any problem solving question. As soon as it pops up on the screen, I want to look at the answers and ask, is this giving me any direction about how to proceed in this particular problem. And that's really what it's all about. It's not about mastering any specific question. It's about, am I learning stuff from this question that's going to help me on future unseen questions? Now, some of you might prefer a hybrid approach. I've seen a lot of people solve it that way, where they do a little bit of algebra and then a little bit of algebraic reasoning. That's totally fine. I think that's fantastic. I'm a huge fan of that kind of adaptation and improvisation of stuff you've mastered in the past. I'm just giving you my specific take on this particular problem without going too much into the weeds for us. So if we were going to do like a more pure math type of approach, we have to get really, really technical really, really fast. And I think that that's going to make this particular approach I'm about to walk you through just impractical for probably 95% of test takers. If you're in the group where this kind of thing really resonates with you, then you're probably just not struggling much with this type of question at all. Like, you probably just knocked it out, and like, you might not even be watching this video. But just in case, let's compare this to what I just walked you through. Now, you might have the instinct to simply multiply both sides by x minus 2, which is a very good instinct in general to try to get rid of denominators, but there's a couple problems with doing that. First of all, if we do that, then that's just going to make x minus 2 disappear from the entire expression, and we'll wind up with this, which is actually taking data away from us that's going to help us figure out the answer to the question. So this actually makes the question harder. Now, on top of that, it's a bad idea to do it exactly that way, because that's not necessarily allowed. And that's because x minus 2 could end up being a negative value. And if it has a negative value, then this inequality sign is going to invert. And we're going to have to consider two different possibilities here. So we'd have to write it out as x minus 2 is positive, and then we wind up with this thing. And then we write it out as x minus 2 is negative, and we wind up with this thing. And really, this isn't the end of the world. This would probably work out for at least some of you, and you could still grind your way to the answer. But in the world of having like the elegant textbook solution, I don't think this is that. This is more of that hybrid approach I was talking about, where like maybe you're going to do a little bit of algebra and then do a little bit of algebraic reasoning and number testing, and there's absolutely nothing wrong with this. But again, I kind of want to avoid just getting into the weeds with this. I'm really just using this as an example of what we're about to have to do to have the like pure math approach. So in order to avoid the stuff I was just talking about, we actually are going to have to multiply both sides by x minus 2 squared. And the necessity of doing that, again, is that thing that I think just takes so many of us out of this being like a practical approach, because I'm sure all of you could execute this, especially if you studied what I'm about to show you, but like, are you realistically going to have this pattern recognition on test day where you're like, oh, this is a situation where I need to multiply by x minus 2 squared on both sides? Now, if that's you, great, great. Don't change what you're doing. Everything is awesome for you on this question. But if you're looking at this like, yeah, Isaac, I don't think I would ever do that, then don't worry about it. This is part of me proving to you why I personally prefer the previous solution path that's maybe a little more basic, if that makes sense. But let's say we do arrive at this place and we multiply both sides, then the nice thing is we're going to get that x minus 2 to cancel out over here, and we'll wind up with x minus 2 times x plus 2 times x plus 3 is greater than or equal to 0. And then 0 times x minus 2 squared is just going to zero that whole side out, so we don't have to worry about that. Now, we also don't have to worry about inverting the inequality, because we know if we square something, it's going to be positive. We know for a fact that if we square x minus 2, it's going to yield a positive, whether x minus 2 started out as positive or negative or not. So that's also the reason to multiply both sides by x minus 2 squared. Now, at this point, we can start to grind on the different values and think about the roots that are given, et cetera, et cetera, et cetera. And there's this whole line of reasoning that you're welcome to take yourself down if you really want to, and this solution is appealing to you. But at this point, in my personal opinion, for the vast majority of students who I've worked with over the past couple decades, those people are not even going to arrive at this point in the problem. They're not even going to get this part to happen. And it winds up being like a theoretically cool, but just like kind of impractical solution. And I'm sure many of you see these kinds of solutions in your day-to-day job, in your business, where some people might have these really fantastic ideas that seem great in theory, but when the rubber meets the road, it's just really hard to execute that particular strategy or that particular plan. And so a lot of times you'll see the best leaders use maybe a simplified approach, but it ends up getting the job done with minimal cost to the organization. And in the world of being a great creative problem solver, which I really think is the skill all of us are developing as we study for the GMAT, combined with being a great decision maker with scarce resources like I was talking about before, this kind of analysis of a question of looking at a couple different approaches and really taking a step back and asking yourself which one of these is realistically good for me is a really good, valuable overall context to have for your studies. Now, if you web search this question, you can find a couple great walkthroughs of this strategy that I was about to go down. I'm not going to go through it because personally I don't recommend it. And again, if you're the type of person who would do this strategy or this strategy resonates with you, you're probably not struggling with a question like this to begin with. But if I'm wrong about that and this strategy really does resonate with you, then by all means use it. That should be the pattern that you build for yourself on questions like this in the future. And if this doesn't resonate with you, then I strongly recommend building the pattern of what I was talking about before of picking some numbers, testing strategically, and just sort of thinking broadly about what's going to happen with positives and negatives in this situation. Okay, so there's two viable approaches to this one. If you have any questions about this, feel free to reach out anytime. We'll be happy to help. And if you're looking to accelerate your progress with your studies and get some structure that might have been missing for you, then check out the link anywhere around this video, and we will happily hook it up for you. Talk soon.